In Chapter 4, we look at reactions that take place in aqueous solutions. Aqueous solutions means they take place in water. There's a lot of different topics, ideas, and skills within this chapter. The first one, the focus of this particular video, is an important one, looking at general properties of aqueous solutions, being able to apply various terms, and consider particle representations and conductivity experiments. Here's how the chapter is laid out. It begins by the focus of this particular video, asking the question, are there free ions in solution? Using that information to classify solutes as strong, weak, or non-electrolytes. Okay, connecting this to the observations that we might make, what happens at the particle level, and how that would be represented with a formula or an equation. It's all brought together by being able to make predictions for whether something is a strong, weak, or non-electrolyte, and what that then means at the particle level and the kind of observations we would be able to make. This is a setup for all of the remaining ideas within the chapter. So we want to get a good foundation on this to begin with. When I look at how the learning objectives are stacked up within Chapter 4, being able to make predictions for strong, weak, and non-electrolytes is one of the more challenging topics. So let's see if we can begin to develop an understanding. Let's start with a few definitions. Non-electrolytes. Molecules are present when a non-electrolyte solute dissolves in the solvent. Solvent, that's the water that we're placing it in. It's the component of the solution that's present in the largest amount. Solute, that's the component that we're adding to it. If we add the solute to the solvent and molecules are present, that's describing a non-electrolyte. If mostly molecules are present, but we have some ions as well, that's a weak electrolyte. And if ions are produced and there are no molecules present, that would be a strong electrolyte. So we're describing solutes as non-electrolyte, weak electrolyte, or strong electrolyte. Evidence of an electrolyte, what could we do for an experiment? The presence of free ions causes a light bulb, a conductivity probe, to go on. So a conductivity probe is a free ion detector. It tells us if we have ions in solution. That'll be the instrument that we can use. So let's begin by classifying water, sugar, and salt using the term strong, weak, or non-electrolyte. We're going to think about it within this framework. Strong, weak, and non-electrolyte. I would say we're going to combine the definitions that we just introduced and consider those to be vocabulary terms that we need to know. We'll be making observations. Observations, those are what our senses tell us. Macroscopically, what do we see? What do we smell? We can use that to make inferences at the particle level. Microscopically or submicroscopically, what's happening? We can't see that directly, but our macroscopic observations can give us insight to what's taking place at the particle level. And we might want to represent that with symbols, such as a formula or an equation. And finally, to make predictions, we have to look for patterns. We can't test just one sample. We have to test multiple samples in order to be able to find patterns. To explore this, I'm going to use the PhET-Sim sugar and salt solutions. If you want to play with the sim yourself, go to the PhET website, and it's called Sugar and Salt Solutions. You notice that it has a macro tab. The designers of the PhET website and these particular simulations, they're familiar with that language that I just mentioned of macroscopic, microscopic, and symbolic. So they have a tab showing macroscopic phenomena. There's different things that you can adjust and play with within the sim. Faucet at the top, considering the water level, whether it evaporates. You can drain it at the bottom, test conductivity, and test concentration. So within the macro tab, our objectives here are to classify water, salt, and sugar as strong, weak, or non-electrolytes, and identify factors that do and do not affect the concentration. And based on your observations, see if you can develop an understanding for concentration. What do you think it's measuring? So let's explore the sim a little bit. We can add water from the top. We can drain it, have the liquid evaporate, make conductivity measurements. So here I'm making a conductivity measurement for water. I'm not seeing the light bulb go on as I manipulate the liquid in various ways. We have two solutes we can choose from, salt and sugar. Shake in some sugar. The solute's going in. I don't see the light bulb changing. I do see some change taking place in terms of the concentration. I don't see the light bulb changing. I do see some changes taking place in terms of the concentration. Let's switch to salt and investigate salt as a solute. Observe the light bulb, observe the concentration. Okay, stop the video. See if you can respond to these two prompts. Classify water, salt, and sugar as strong, weak, or non-electrolytes. And what do you think is going on with the concentration? What was affecting the concentration or not affecting the concentration? And based on your observations, what do you think the concentration is measuring? Pause the video and respond to those questions. Now let's shift to the micro tab. First of all, compare this image with the macroscopic representation. What have the designers added to this microscopic representation? What has been removed? Playing within the micro, we can add sodium chloride and sucrose. See the elements that are present for each. Adding sodium chloride. We are now going to see what happens at the particle level. And we'll also add sugar or sucrose. What will happen at the particle level when we add sucrose? It also dissolves, but it seems in a different way. So with having used this one, we now have information at the particle level for what happens when sodium chloride or sucrose is added to water. What I'd like you to do is connect what was shown in the microscopic and macroscopic representations. Use terms like solute, electrolyte, and conductivity in your response. Here's another sim, or another tab, another opportunity for me to play within the PhET sim and explore, in this case, sodium chloride and calcium chloride. So we're familiar with what happens when sodium chloride is added to water. We've seen that at the particle level and also macroscopically. How about calcium chloride? What's going to happen when we add calcium chloride to water? I want you to make a prediction. What's going to happen at the particle level? How will this be similar or different to when we added sodium chloride? And tell me about what's going to happen to the concentration data. Pause the video, make your responses, and then we'll check within the sim. Adding calcium chloride. Was your prediction correct? If not, how has your understanding changed? Would you say calcium chloride is more similar to sodium chloride or more similar to sugar when it dissolves in water? Pause the video, share your responses. Another pair of solutes, sodium chloride and sodium nitrate. We're getting more familiar with seeing what happens with sodium chloride. We also have the opportunity to add sodium nitrate. So I want you to make a prediction. The solution initially contains sodium ions and chloride ions because we added sodium chloride. What happens at the particle level into the concentration values when sodium nitrate is now added to this solution? Make a prediction, share your answers. Let's check. So we have both a particle level representation and we have the concentration data changing. So you had made an initial prediction. Were you correct? In what ways do you think a student might make an incorrect prediction for this scenario? If you weren't quite right, in what ways did you err? If you were correct, where do you think a classmate may stumble on this scenario? One more pair to look at. So the solute choices now are sucrose and glucose. We see different formulas. We'll add sucrose first. Glucose is another type of sugar. Once again, I'd like you to make a prediction. What will happen when the glucose is added to the water? Do you think it will be more like sodium chloride, sodium nitrate, or sucrose? I want you to explain your reasoning and use terms like strong, weak, or non-electrolyte in your response. Let's check. Moving on, here are some end of chapter questions on this subject. So the first one, 4.1, is showing particle level representations. And the second is asking what ions are present when the following substances dissolve in water. These are quite representative for what exam questions would look like on this topic. We're not going to have you play with a PhET sim, but we're going to ask questions that are related to what we saw within the PhET sim with questions like these. Give them a try. So within this video, we were exploring what does it mean to say there are free ions in solution. the kinds of observations we can make, and what takes place at the particle level. This is going to be a setup for the ideas that we go on to explore within the chapter. I think that if we have a good understanding for what this first property is in describing things as strong, weak, and non-electrolytes, it's going to really help to explore the other ideas.